Find the volume of the solid that results when the region enclosed by the curves is revolved around the y equals -1 axis. All right. So what this looks like is a washer's problem. And what we're usually used to in a more basic, even though it's difficult, version is you're used to spinning it around the x-axis. Well, this is different. So when it was spinning it around the x-axis and you use the washers, you have your lower limit, you have your upper limit. You throw a pi there. Okay. And when it's washers, you take what you determine to be like the upper curve, which is RO, which this is the case, and we have RI here. What you did back then is you would say RO squared minus RI squared dx. Well, when it was the x-axis, y is 0. So that was fine. But now that we're spinning it around a different axis, we have to change things up a little bit. So let's erase some of this because we are adding another unit when we spin it around. If we were to spin it around the x-axis, no big deal. But now when we spin this around, we have to pretend that this guy is creating like this weird donut-looking shaped thing here. I can't draw. But it kind of creates a bowl where actually you have to believe that there's like a hole in the middle. So we kind of have this weird looking donut-y thing. Okay, but we're adding another unit. So whatever number y is, the best way to probably view this as minus y. Okay, where in this case y is -1, so it'll become +1, but then you take that, you square it, and then you subtract r sub I, do the same exact thing, square that, close it, dx it. So that's what we're looking at. Now, the other thing that we have to take care of is even though it's kind of obvious, we can never have the benefit of the doubt and say that that's definitely 0 and that's definitely 1. So we need to find out what my upper limit A, or B rather, and my lower limit A is. So I'm going to do that by finding out where these two guys intersect. So we're going to pretend that that's a system of equations, and we can solve that using substitution and say root x plus 1 equals x squared plus 1, bada bing. Let's set this equal to 0. So let's subtract root x. Let's subtract 1. Let's subtract root x. Let's subtract 1. That goes away, and you have 0 equals x squared minus root x. Okay? The way I'm going to handle this is I'm going to use zero product property, and this is going to be strange, but go with me here. I'm going to factor out a root x. By factoring out a root x, I am left with a root x cubed, or x to the 3 halves, minus 1. And we could use the zero product property. Root x is equal to 0. So this factor equals 0. Square both sides. X is still equal to 0. So that gives me that guy. My lower limit, it's kind of obvious. My upper limit should be 1, but, just to be on the safe side. Square root of x cubed minus 1 equals 0. Add 1. Square root of x cubed equals 0. Square and cube root both sides. X is equal to 1. I'm sorry, 1. 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. I'm getting too jumpy here. Getting too jumpy. All right, so now what I have is I have my upper limit. I have my lower limit. Time to have some fun. Let's call u 1, let's call u 0, and let's write small. See what happens. Let's get rid of all of u. If you have to, clear that out, clear that out. All right. Pi, integral, upper limit, lower limit, bracket, r sub o I called the square root. So I'll call you r sub o, I'll call you r sub I. So this is going to become r sub o, which I don't know why I did that. R sub o is root x. So I'll write that as x to the 1/2. Makes sense to me. Plus 1 minus -1, so plus 1 again, squared, minus r sub 2, or r sub I, minus r sub I, which is going to be x squared plus 1 minus y, which is negative 1, so plus 1 again, squared, bracket it, dx it. Okay, so let's do a little bit of simplifying. Pi still lives there. Far from integrating. So if I were to do that, that becomes x to the 1/2 plus 2 squared minus x squared plus 2 squared dx. Okay, let's do... we've got ourselves two perfect square trinomials that we're going to end up with. So this is going to become x plus 4x to the 1/2 plus 4 minus, this is going to become x to the 4th minus, or rather plus 4x squared plus 4, close it, bracket it, dx it. Okay, let's try to simplify and distribute the negative at the same time. This is going to be interesting. So x isn't going to be touching anything else, so x is just x. Plus 4x to the 1/2, that's not going to be changing anything either, so plus 4x to the 1/2. Plus 4 and minus 4 will cancel out. We've got minus x to the 4th minus 4x squared. That's our integral. There you have it. So I'm going to leave that down there. And I'm going to do the integration up here after I erase everything. This is going to be a mess. However, the nice thing about this problem is since the lower limit's 0, things will go away, and that's going to make our lives a whole lot easier. Okay? All right. Pi still lives out there. The integral of x is 1/2 an x squared. Okay. The integral, this is going to be an interesting one, of 4x to the 1/2. The 4 is going to live there. And then you get 1 over 1/2 plus 1, which is 3/2. So 1 over 3/2, right? And I'm just going to do the math right here and then erase things. 1 over 3/2, when you divide by a fraction, you just get its reciprocal. When you divide 1 by a fraction, you get its reciprocal. So 1 divided by 3/2 is 2/3. And you end up with 8 over 3. X to the 3/2. Okay. Minus 1/5, x to the 5th, minus 4/3, x to the 3rd. My limits are 1 and 0. All right. Pi 1/2 x to the 2nd power is now 1 to the 2nd power. So you tell you what, let's make life easier. If we're doing the fundamental theorem of calculus, 1/2 times 1 squared is just 1/2. Let's not overthink it. Plus 8/3 plus 1, or times 1 rather, so plus 8/3 minus 1/5 times 1 minus 4/3 times 1. That guy's done. Minus pi. And I'm going to plug in 0 for all of these. So 0 times stuff, who cares? 0 times stuff, who cares? 0 times stuff, who cares? 0 times, they're all going to become 0. So this ends up being pi times whatever this guy is. I'm just going to let Siri do it. 1/2 plus 8/3 minus 1/5 minus 4/3.
It's approximately 1.6333.
I'll take that. 1.6333 times pi is going to be 1.6333 pi. So that is the volume of a washer bowl thingy spun around an axis that is not the x-axis. Very tricky problem. Tons of fun, though.